to my channel. Today, in this video, we're going to be interviewing Dr. Cortinas, who is the Deputy Assistant Administrator for Science at the National Oceanic Atmospheric Administration. And he basically focuses on weather forecasting, and he uses a bunch of technologies to try to actually weather forecast. So let's get right into this amazing interview.
The technologies that we use are helping us to collect more observations more effectively, covering greater areas. There are continuous improvements being made all the time as we learn more about how the atmosphere works. We use computer models. We have historically used computer models. That's the history of how weather forecasts have been created. But increasingly now, with the advent and more information about AI and machine learning tools, we're actually applying that to ways of forecasting the weather and improving those forecasts.
So here, guys, we have the man himself, Dr. Cortinas, who is the Deputy Assistant Administrator of Science at the National Oceanic Atmospheric Administration. Wow, a very long title. So, welcome to the show, Dr. Cortinas, and I'm really happy that you are here today and we're able to actually interview you. So, yeah, welcome.
Thank you. It's my pleasure to be here with you.
So we'll start asking you a few questions to actually know you better, and like what inspired you when you start, and questions about that, like that we'll do with everyone so that we just know them better at the start. And then we're gonna ask questions more about the NOAA, aka the National Oceanic Atmospheric Administration. So let's get right into the video. So actually, what inspired you to do this? What inspired you to do a career here?
So I was very interested in weather from a very early age, and that's really what got me interested. So I grew up in the United States, right in the middle of the United States, in the state of Nebraska. And that part of the country experiences a whole wide range of weather, including heavy snowstorms, tornadoes, heavy flooding rains, a whole variety of types of weather. And I think that was one of the things that really excited me about that field, to just learn more about it, because I was naturally inquisitive about my environment, the things that were happening. And so after experiencing that, it was something I wanted to learn more about, and I decided that's the thing I wanted to study in my career.
So you, like you said, as in a young age, you just was inspired of actually this phenomena and how random and how powerful these storms can be. So very good. And actually, when did you actually start this? So you started right at a young age doing this job, or when did you actually get into this career? When did you actually start planning to get into it?
So my initial interest was when I was in junior high school, and then through high school, I took the necessary science classes that I needed to prepare myself for going into college to get a degree in meteorology. And so that's what I focused on. And so I went and worked on my college degree in meteorology specifically. And shortly then, after I finished my degrees, I started a position with the National Oceanic and Atmospheric Administration at one of the universities that they work closely with in Norman, Oklahoma.
Okay. So right after studying and right after coming from school, then you started your career in that. Okay.
All right.
And well, now that we know more about you, let's ask more questions about NOAA. So first of all, tell us about your academic studies and how you started your actual career. So what we have.
Sure. So in the field of meteorology and understanding weather, it's very science-based. So as I worked on my degree, it requires a lot of courses in physics, in mathematics, in understanding how the atmosphere works. So there's many courses, as you would expect in this degree, that focuses on the atmosphere and applying the physics of fluids to how the atmosphere behaves. And so that's really the main driver, how we understand what's happening in the atmosphere. It's simply air is a fluid just like water. And so the equations and the knowledge that we have about how water behaves also applies to the atmosphere. And so that's what the field of meteorology does, is that it applies the equations and the understanding of fluids to the atmosphere. And that's the basis of what we do. And so my initial interest was looking and understanding how severe weather occurs. And ideally, as a meteorologist, my interest is trying to understand how we can help improve our ability to produce forecasts and predictions to alert people before the kinds of weather, severe weather occur, so that they can prepare themselves and protect themselves. That's ultimately what we're trying to do as meteorologists, and understanding how weather. So we put a lot of effort in increasing our knowledge and understanding of how the atmosphere works, how severe weather, thunderstorms, tornadoes, hurricanes all form, and then applying that knowledge and use various tools such as computer models to then help forecast and predict how the condition of the atmosphere will be in the future. And therefore, by understanding that, we can share the information with the public and other people who need to protect themselves. And so that's what we do.
Wow. So very cool. Okay. And actually, what are your main challenges in forecasting tornadoes, and how NOAA is improving tornado prediction? Because we know that that is a huge cause, like you just mentioned.
Absolutely. So the phenomenon of tornadoes and the severe storms that create them is still a bit of a mystery to us. It's because they form so quickly and they only occur over a relatively small area. It's difficult for us to collect the observations because, as you know, the winds and tornadoes can be as strong as 200 miles per hour. And so trying to get observations of the atmosphere around those storms and even in those storms is extremely difficult. And so that has limited our ability to further understand how things form. But because increases in terms of our technology, such as the use of radars and other kinds of instruments that we're able to now measure around thunderstorms and tornadoes, has helped us to better understand how they form. And so we are now in the process and the ability to create models, computer models, that can simulate that formation process. Of course, we don't have all the details. There's still a lot to learn, still a lot to understand. So we continuously invest in improvements in types of instruments that we use to measure these kinds of phenomena. And then we'll use that to help us improve the models that we use as well to predict those storms. But today it's still very difficult for us to predict where a thunderstorm that can produce a tornado will occur. They just happen so rapidly, and we don't have all the observations we need continuously monitoring the atmosphere in order to make those kinds of predictions. But we're getting better.
And you would say that you're getting, like, on terms of the scale, how close you think you are getting to that goal? Like what? Halfway there? Three-quarters there? Approx?
It's very difficult to estimate that. We have had some recent successes, though. Some of the computer models that we use most recently is that we were able to identify in a general area um, about 45 minutes or so before the actual tornadoes occurred. So that's the kind of lead time that we call, the kind of time before the tornadoes occur, that we can let people know so that they begin to take the necessary precautions to safeguard themselves and their property. So we're making a lot of significant progress because in the past it was only a few minutes or so that we were able to identify those
Mm-hmm.
storms.
Okay. So like you said, close, right? And actually, how is NOAA working to better predict severe weather like hurricanes and thunderstorms, like you said?
Yeah, we're actively involved in, as I said, one, improving the kind of observations that we collect. The technologies that we use are helping us to collect more observations more effectively, covering greater areas. So we use and rely very heavily on satellites. Those satellites measure from space what the weather is happening on the Earth's surface. And the more details that we can obtain from those satellites, the better our understanding of what's happening. So we've just recently launched a new satellite that is positioned now for NOAA to be able to use and monitor 24 hours a day, 7 days a week, all the time, for us to monitor those weather conditions with much greater accuracy and better resolution. So we rely very heavily on those kinds of satellites. We're continuing to make improvements in that so that we have better observations. We can also measure through those satellites not only what we see, but information in the atmosphere that's important to us, like understanding the temperature of the atmosphere at various levels, looking at how much moisture is in the atmosphere at various levels. So that additional information is extremely important to us because the more we understand, the more we know about what's happening in this moment in the atmosphere, the better that we can predict how it will evolve in the future. And so a focus is also on observations, not only in satellite observations, but we're also looking at the next generation of weather radars. So we're all familiar with looking at information from the television, on the web, etc., and looking at where the rain is occurring. Well, radars not only determine where rain is occurring and its intensity, but also give us more information about the winds around those storms, what kind of rain is occurring, what information of other things such as hailstones. We can detect that kind of thing. And so the more that we understand and the more that we can observe, the better we'll make our forecast. And then lastly, the other thing we're investing is improvements to our weather forecasting models. There are continuous improvements being made all the time as we learn more about how the atmosphere works and how we can better use all the observations that I just described. And so we have a lot of research and a lot of work that's being done on trying to incorporate all that information. And then the other thing that we're looking at and have invested in is understanding how people understand and interpret the information that we're sharing with them about the weather. So, what actions are people taking when we say there's a tornado coming by? What are the things what is the information that we can share that might help people better prepare than we are today? There are other examples of weather maps that we provide, or maybe you may have seen on the television or on the internet where your country may be identifying areas where there are strong storms occurring. And they may indicate that with a box that has a red color to alert you to say that's an important area to be concerned about. But the question is, do all people respond in that way to those colors and those shapes? And so there's a whole area of social sciences that looks at how people interpret information and how we share that information. So that's critically important to us on the weather side, because if we're going to share information to people, we want to be able to share the information that they're going to make them take that necessary action to make them and protect
Okay.
themselves. So we have a lot of work in that area as well too.
Mm-hmm. So, how are AI and machine learning being used to improve well weather forecasting, and do you actually use that at NOAA?
That's a great question. And absolutely, we're looking at the use of artificial intelligence, in particular machine learning, on how do we improve our weather forecast. So, as I mentioned, we use computer models. We have historically used computer models. That's the history of how weather forecasts have been created. But increasingly now, with the advent and more information about AI and machine learning tools, we're actually applying that to ways of forecasting the weather and improving those forecasts. So improving the forecast, but also how it more effective it is in terms of using machine learning tools. So we're really making advances in that area as well, and we've been very encouraged by the results that we've seen. That the information that we're receiving through some of the machine learning tools that we're actually implementing are becoming very close to what we're able to currently do with computer models that we're using today. So we think the opportunity for further increases, better use of our computing systems, etc., is going to be significant in the very near future
All
for
right.
sure.
And of course, AI is going to be developing much more in the future too, so it's going to be helping both ways. And
Absolutely, and I think it can also play a role in how people receive information, how we share information, the level of detail and information that people can receive, I think is all going to be aided by the use of AI for sure.
And how is NOAA adapting its methods to dealing with effects of global warming on weather prediction? You know it can
Certainly,
mess
global.
up. It can mess up everything.
Okay, certainly global warming is extremely important for us to consider, and we're looking at those impacts of global warming on weather in the future and the impacts and whether it may be more severe and how do people prepare for that future scenario with global warming continuing.
All right. And then, of course, you're adapting your missions to be able to adapt to that and to have, yeah, better understanding of that. And what are some key milestones in your history of weather forecasting, and how has technology actually changed the field?
Well, technology has made significant improvements in terms of our ability to understand the weather and then predict it. I already mentioned a number of things, technologies that exist today that started not that long ago. I've mentioned satellites. They allow us to see the Earth from a distance and look at the weather that's occurring in very fine detail continuously. Radars have been significantly an improvement for us understanding how weather occurs, particularly around these severe types of weather. And then various other instruments. Most recently, we've been using drones for collecting observations around storms and in areas where we can't go because of safety issues for humans. For example, in the middle of hurricanes, we've been testing air drones for a few years now that are deployed from our aircraft that actually penetrate hurricanes. Once they're in the hurricane, they release the drone into the hurricane and they collect measurements that go all the way down to the ocean surface. These are areas that we can never go as humans, but because of the use of drones, we're able to look at those. Not only are we using drones in the atmosphere, we're using drones in the ocean. So the ocean plays a very important role in weather, particularly in hurricanes. And so we've deployed drones that are in the ocean. They take measurements in the ocean. They go up and down, if you will, and go in various areas of the ocean where we know hurricanes can form. And so by collecting those observations in the ocean, we're also finding that that information is critically important to understanding how hurricanes are intensifying or dying down. And so we're using all kinds of new technologies that are making a big difference in how we're able to predict what's happening in the weather.
All right. And how does studying Earth's weather help scientists understand weather on the moon or Mars for space missions?
Well, as I said before, the air is just another fluid like water, etc. And so those other planets that have an atmosphere, understanding how our atmosphere works here can help us understand then how an atmosphere would work on any planet. So
Right.
the information that we have, the knowledge, observations, and the understanding that we have using basic physics will help us understand how planets and weather on other planets can occur as well too.
Okay. Well, finally, we're at our last question. What is your message to the people watching?
Well, I think it's important to understand that it's up to each of us to make sure that we're taking the necessary precautions when severe weather comes by. But be alert and make sure that you understand what you need to do when severe weather happens, but also understand what we can do on our planet to ensure that our future climates, the one that we need to survive.
All right. Well, thank you for this amazing interview, Dr. Cortinas, and thank you.
My pleasure.